All right, IM3 classes. Today we're moving on with multiplying polynomials. We're going to learn how to expand binomials using what's called the binomial theorem. The first part of the lesson in class is we're going to go over Pascal's triangle. This is going to be important for the lesson today, but we're going to explore the different patterns. This is a famous number pattern created by this French mathematician named Blaise Pascal. You'll have to ask Mr. Mangar about proper pronunciation of his name. But Pascal, one of his contributions to math is this triangle. You do need to know how to create this triangle. It's very simple. This is something we're going to use a lot in the next couple days. So using Pascal's triangle, how to create it, one thing you need to notice is each row starts and ends with 1. So every row starts and ends with 1. All right, to get the middle numbers, the numbers on the inside, what you do is you add the two numbers above it. So 1 plus 1 is 2. All right. So 1 plus 2 is 3. 2 plus 1 is 3. And you add the two numbers above it. So 1 plus 3 is 4. 3 plus, I should do, because now it just looks like a bunch of X's. But you're starting to get it. So 3 plus 3 is 6. And so that's how you get the next row down here. All right. And you just keep moving on. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So it keeps going down, expanding. All right. Again, in class, I know if you're watching this video, you probably didn't, you probably weren't in class, but we are going to be using this a lot, and you do need to know how to quickly get out like the first 7 rows. We never do more than like the first 7 rows. Notice that starts with row 0. That's another important part. But what we are doing today is learning how to expand these binomial. So binomial expansion, really all you're doing is multiplying these. So if you remember from the lesson with multiplying polynomials, when you're squaring a binomial, you have to multiply itself or times itself like this. You don't just square both things. And then you distribute, so x times x is x squared, x times y is xy, y times x, xy again, and then y times y is y squared. Combine like terms in the middle, so you get x squared plus 2xy plus y squared. All right. So that's pretty simple to expand something where it's just a 2. What we are going to be doing today is learning what to do if this is bigger than 2. So what if it's like a 3? So what this would be x plus y cubed, or not cubed, excuse me. Cubed would be x plus y times x plus y times x plus y. We can do this. It takes a little bit of effort. It's not that much fun, but if we multiply this out together, I'm actually going to take a little bit of a shortcut since we just did this on the last slide. I know that it comes out to x squared plus 2xy plus y squared. All right, so x squared plus 2xy plus y squared. And then you multiply it by x plus y again. So this simplifies down here. I'll do some highlighting. So these two multiplied come out to this. Again, not doing that all again. And so then we're multiplying by this out here. All right, I'm gonna just reorder it the way we're used to seeing it, so we're not confused. I'm just gonna flip those around because we don't like to distribute backwards, even though it doesn't really make a difference. You can do this. So now I'm going to distribute again. So x times x squared is x cubed. X times 2xy, careful with that, that's 2x squared y And then x times y squared would be x y squared. I give myself a little space, distribute the y, so it's going to be x squared y. Put it right underneath this one. Then y is going to be plus 2x y squared. And then one more, I'm sorry, it's getting messy, plus y cubed. And so we get, after you add those, x cubed plus 3x squared y plus 3xy squared plus y cubed. So there we go. So all that. So that's more tedious, right? You got to do it all again. So what if we even go a little bit higher? X plus y to the fourth, right? Do we really want to go through that whole process again, where we multiply everything by x plus y times x plus y times x plus y? No, we do not. That's a pain. We're not going to do that, right? There's a shortcut to this. One thing I want to point out, and that's where, excuse me, let me back up. There's a shortcut to this, and that's where Pascal's triangle comes. All right. So what we're going to use is Pascal's triangle to do this real quick. What I want you to notice here. So the coefficients for x plus y squared are 1, 2, 1. Take a look at the coefficients for x plus y cubed all the way at the bottom here. It's, if I put them in, it's 1, 3, 3, 1. So 1, 3, 3, 1. All right. So when you get there, and if we look at the Pascal's triangle, row 2, 1, 2, 1. Row 3, 1, 3, 3, 1. So x plus y to the fourth, those coefficients, believe it or not, are going to be 1, 4, 6, 4, 1. So this is where we can use Pascal's triangle to quickly expand polynomials. So we're going to skip over this. We're going to use Pascal's triangle to expand x plus y to the fourth. So what we're going to do, move this out of the way, we're going to write out the fourth row of Pascal's triangle, make sure we're going to give plenty of space between the numbers. So I'm going to quickly write out the first 4 rows of Pascal's triangle. So you know what it is. So it starts with 1, 1, 1, and then you add these together. 1 plus 1 is 2. Starts with 1, 1 plus 2 is 3, 2 plus 1 is 3, and then 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and there we go. That's the fourth row. So it starts at row 0, fourth row. So I'm going to write out those numbers: 1, 4, 6, 4, 1. Plenty of space in between them. Give each number an x and a y. Because we're using x and y's, this will change depending on what these variables are. So it's going to be x, y, x, y, x, y, x, y, x, y. The exponents for the x start at 4 and go down to 0. So it starts with whatever is here. So it's 4, so I'm going to go down 4, 3, 2, 1, 0. Then I'm going to go backwards. So the exponents for y start at 0 and then go up to 4. 0, 1, 2, 3. There is a 1 there. I did. That's 4. One way to double check this, make sure the exponents add up to this. So 4 plus 0 is 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. 0 plus 4 is 4. All right. And then we simplify. All that you need to do today when you're simplifying is take care of the 0 exponents. And then if the coefficients are positive, you're going to put a 1 in front of them. So, or excuse me, a plus sign. So 0, anything 0 power is 1. So y to the 0 is 1. So this is 1 times x to the 4th times 1. That's just x to the 4th. And then this is going to be plus 4x cubed y to the first plus 6x squared y squared plus 4x to the first y cubed. So I will need to put the first there. Plus, this is 1. I should actually note that so we're clear. So this is 1. This is 1. So 1 times y to the fourth is y to the fourth. And we are done. So instead of multiplying everything out, we just use Pascal's triangle to figure out the coefficients and then follow the pattern of increasing and decreasing exponents on each of the variables. So let's do a bigger example this time with a negative. All right, so we're going to do the fifth row. So I'm going to do a different slide here so we can see the fifth row. So 1, 1, 1. So then 1 plus 1 is 2. 1 on the outside, 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1. And now we're at the fifth row. Again, so 2 ways to determine the fifth row. So it starts at row 0. So 0, 1, 2, 3, 4, 5. Or the first time you get something, you can just tell by the first number here. So row 1, 2, 3, 4, 5. All right, so my coefficients 1, 5, 10, 10, 5, 1. 1, 10, no, 1, excuse me. 1, 5, 10, 10, 5, 1. Be careful with the negatives. So they're each going to get a x and a negative y. X and a negative y. X, negative y. X, negative y. X, negative y. X, negative y. So the coefficients on the x start at 5 and then go down to 0. So 5, 4, 3, 2, 1, 0. And then 0, 1, 2, 3, 4, 5. So the only thing that's going to be different about this one is the negative. When it's if it's an even exponent, that's going to make it a positive because it'll be like negative y times negative y is a positive y squared. So we just need to be careful with that. So here, anything to the 0 power is just 1. So this is 1. So 1 times x to the fifth times 1 is x to the fifth. Here, this is going to be a negative y to the first is negative y. So this can be minus 5x to the fourth y. So we're taking the negative, moving out front. So negative y squared is positive. So we're going to plus 10x cubed y. Odd numbered exponent, this is going to be a negative. So you're going to be minus 10x squared y cubed. This will be a positive, so it's going to be plus 5x y to the fourth. And then this last one, the x to the 0 is 1. So that comes out to actually minus y to the fifth. So there we go. All done there. What I want to point out, a couple things. So if you have a negative in there, what's going to happen is that it's going to alternate positive and negative. All right. Your first one is always going to be, usually it's actually going to be positive. I shouldn't say it's always going to be positive. It depends. It's not always going to be positive, but it's when you have a negative in there, it's going to alternate. It's also going to depend on this coefficient here, because sometimes it will add, right? If this was a 6, you know what? No, never mind. Back up. Thinking backwards. Never mind. It just alternates. Just make sure you pay attention. Easy way to tell. Odd numbered coefficient is going to make a negative. Even numbered coefficient exponent, odd numbered exponent, going to make a negative. Even numbered exponent is going to make it positive, and that's when there's a negative there. And that is it for binomial expansion. Make sure you let me know if you have any questions, and we'll see you guys next time.